Okay, so let's have a look at nuclear energy and what is the principle of how it is being produced. Yeah. So Japan relies a lot on nuclear energy. They don't have fossil fuel resource, so this is one of their main source of electrical energy. Okay, so this is not the picture of Marie Curie, but this is the picture of an actress. Okay, and this is a movie on the life or the research life of Marie Curie, who Marie Curie and her husband founded, yeah, the radioactive material and radioactive reaction, okay, element, and they have Marie Curie have won two Nobel Prizes. The first lady to won Nobel Prize, and she won double Nobel Prize for her finding in nuclear chemistry, in nuclear technology. But this is not the face of Marie Curie. This is just I'm showing you the face of an actress who act as a Marie Curie in this film. So you can watch this film, very interesting, looking at the life adventures of researchers, especially ladies at the beginning of scientific revolution. So that there are not many scientists, especially ladies, at that moment. If you look at the picture, where you have Einstein and all other scientists, she is the only one. She is the only lady scientist. So it is very challenging for her to put herself in the line of other scientists. And this is the picture of her daughter, okay, and his son-in-law, her son-in-law, okay. So what Marie Curie have found is more on natural occurring radioactive, okay, the natural occurring radioactive elements. So she actually found out about radioactive activities from the elements that naturally occurring. Okay, so but her daughter, okay, and her son-in-law, okay, discovered about artificial radioactivity, meaning that you can synthesize the isotopes that can radiate radioactive activity. Okay, so Marie Curie found about the naturally occurring radioactivity, but daughter discover the artificial radioactivity. Okay, so please do watch because their finding comes with with a price, yeah, because they do not know at that moment that the radioactive is actually toxic to human being. So the researchers died to the exposure of the radioactive compound. Okay, so it's a bit sad story. So please do look at them. Why their sacrifice has helped us a lot. Okay, so how does radioactivity give us energy? Okay, so when we talk about chemical reaction, we are talking about transfer of electron, whether it receive or whether it contributes electron. Okay, so when talking about chemical reaction, it's about electron. Okay, but in radioactivity or radiochemical, we are talking about the nucleus, the one that contain proton, neutron. Okay, so it's not about electron, it's about the nucleus. So there are two main process or two main reaction happen. It's either nuclear fission. Okay, fission means that you split the nucleus. Okay, so for example, this is uranium 235. What does it mean by 235? If the isotopes, yeah, So if you search for the definition of isotopes, you should know in chemistry, you have a basics in radiochemistry that you have proton number, okay? And then you have uh, what do you call atomic number, okay? So you have to know that uh, that nucleus uh, will basically contain a neutron, certain numbers of neutron and certain numbers of proton. Okay, but isotopes, dif when we see this kind of isotopes, uranium 236 and uranium 235, uranium is the same element, but the number of neutron, the number of neutron is not similar. So this is what we call as isotopes of uranium. Okay, isotopes of uranium because they have different numbers in terms of neutron. All right, so what happened is for nuclear fission is we use neutron, okay, to bombard the nucleus, and from the bombardment, okay, uh, okay, so what happened is knockout of some neutrons, okay, from the nucleus. I use the word knockouts, but yeah, it splits, okay. The neutrons go out, and due to that, now the elements are no longer uranium, but they have changed into other elements because of the neutrons now is not similar. Okay, these are all basic that you have learned. So the process of this fission produce energy. That's the most important that I want to tell here. It's not about the chemistry of the nucleus, but the process of getting the energy is from the bombardment of the nucleus, where the nucleus uh, will be changed into some other element, and in that process, producing energy. And the opposite can also happen, which is the nucleus can be fused together. So you can see that the nucleus from deuterium, the nucleus from tritium element, you can fuse them together, okay? That's why it is called fusion. And the process of fusion, okay, will also release a lot of energy. So that is the basic of energy from nuclear, comes from nuclear fission and nuclear fusion. Okay, so this is the nuclear reaction, okay, not a chemical reaction. It's a reaction that happens based on the nucleus of atom, okay. Right, nuclear energy is considered low emission or green energy because it produces electricity. So because of the energy from the fission and the fusion can be transformed into electricity without directly emitting greenhouse gases like CO2, sulfur dioxide, or CO. Okay, so that is considered green. However, in terms of renewable, okay, it is renewable, okay, because you can still get a lot of isotopes, okay. It is not like fossil fuels that is actually produced million years ago, and it is in fact depleting, okay. So for nuclear, you can still use elements, okay, a lot of elements on Earth, but uh, there are still some issues. For example, the resources, of course, it is not unlimited. It is also limited. It relies a lot on uranium, a non-renewable resource, although it can be recycled. Waste production, okay, nuclear power plants produce radioactive waste, which requires careful management. Yeah, okay, this is definitely a big issue for the waste management and the storage of the waste, as well as storage of the uranium itself before it can be used. Okay, so it is risky, but then it's a good alternative, yeah, for fossil fuel. Nuclear energy production can have environmental impacts related to uranium mining, okay, and enrichment. Okay, this one also, of course, one of the issues in nuclear energy, right? So nuclear energy has a growing recognition, okay, being recognized as a crucial part of the solution for achieving net zero. Net zero meaning that zero carbon emission, yeah, by 2050, particularly as a bridge to fully renewable energy system. So nuclear energy is considered one of a alternative. However, nuclear energy faces public perception, definitely. If we heard about nuclear, everybody will be scared. The issue of waste disposal, the radiations, okay? So there are still things needs to be handled, right? So the reactor, uh, the place to put the reactor design, the safety of the reactors are the concern when we are talking about nuclear reactors. Okay, so coming back to the basis of nuclear reaction. So this is the one that I have talked about, isotopes. Okay, so not all isotopes are radioactive. Okay, I repeat, not all isotopes are radioactive. Only isotopes with unstable atomic nuclei. Atomic nuclei means the nucleus of the atom. So the one that is unstable is radioactive in nature and are called radionuclides. Okay, so isotopes with unstable nuclei, atomic nuclei, are radioactive in nature and are called radionuclides. Radioactive in nature means that naturally it will become radioactive and radiates, okay, have some radiation. Okay, so radioactive isotopes undergoes nuclear reactions, meaning that they will emit certain high energy particles or electromagnetic radiation in order to be stabilized. So it happened naturally. Okay, so that's why it is quite natural. It's happening everywhere. If the isotopes, radioactive isotopes is there, then it will naturally be radiate some radioactive wave. Yeah. So by the early 1900, physicists realized that the mass of particle could not always be treated as a constant. So, so this is where they become aware of uh, the energy inside the atom. Okay, so it's about mass defect. Okay, what is mass defect? The mass difference between, okay, let us look at the calculation actually. It's better to understand because we understand that the nucleus contain proton and neutron. So for example, if we have helium-4, okay, so helium-4 means that it has 2 protons and 2 neutrons, okay? So if if we can have calculation of rest mass, meaning that the mass of the one that identified for proton, okay, this is the mass. And then for total up the rest mass for helium-4, we total up times 2 times 2. So it is 4.001506. Okay. So there is a mass defect because if we calculate the actual molecular weight, molecular weight of helium, okay, if you look at your periodic table, and then minus the rest mass of the proton and neutron, because electron is actually very, very low in mass. Okay, so using the Einstein equation, we can calculate the energy. Let me move this to the top. Okay, so based on the difference in terms of mass, molecular mass, the molecule mass of helium and the rest mass of the proton and neutron. So we can calculate the energy difference using Einstein equation. So Einstein equation is just I don't remember I have taught this one, but I don't remember. Is this is this is the speed of light. Okay, this is the constant. I don't remember, sorry, but this is the one that we can use for the E equal to mc squared. Yeah, mc squared. Yeah, this is E equal to mc squared. Yeah, the Einstein equation, E equal to mc squared. So c is the speed of light squared, power of 2. And this is the mass, but the unit is converted into kilogram because U is not it is a mass unit. So, but you need to convert into kilogram. So finally, we can get the energy in the form of joule. So this is the famous Einstein equation, E equal to mc squared. And if we can calculate for 1 mole, this is the energy for one atom. If we are talking about 1 mole of helium-4, then this is the energy that can be produced based on the mass defect. So this is actually the one that started with the energy of the nucleus, and this is called binding energy. What binding energy is? Because the energy is needed to make sure that proton and neutron stays together in the nucleus. Okay, so that is the potential energy, which is called the binding energy, that sustain the proton or neutron to be in the nucleus. So if we break this energy, the energy will be released. Okay, so the energy comes from this. The higher the binding energy, the more stable the nucleus, meaning is that it's difficult to break the nucleus. Of course, you need to have a very high binding energy to split or do the fission of the nucleus. Right. So don't worry, you're not going to do any calculation whatsoever. So I have discussed about nuclear fission and nuclear fusion, fission and fusion. Okay. All right. So this is the difference. So for fission is the breakdown. Okay. Reaction does not occur naturally. Of course, you have to bombard the nucleus with neutron. Okay. And it produces many radioactive particles. After the split, it changed to other elements and other radioactive elements. If I can show you back the picture. Oh yeah, this one. Okay, energy release is million times greater than in chemical reaction. So chemical reaction, we have endothermic, exothermic, and we understand that from the chemical reaction we get energy, but in terms of fission or nuclear energy, it is million times greater. So that's why it is a very good source of energy. And you have also heard about atomic bomb. Okay, this is how you get the bomb. Okay, so another one is fusion. Okay, fusion, remember the fusion is we match, make it, I think, okay, we combine, yeah, the nucleus together, right? So we fuse them together. A few radioactive particles are produced, meaning that not that many. You can see that it's just helium in this case, okay? But requires fusion trigger, okay, for the fusion reaction to happen. But the energy is greater than fission. Okay, so we are talking about a lot of energy. Right? Okay, so so I'm not going to discuss this. It's radioactive reaction or radioactive radiation. Okay, decay is actually common. Okay, so example of decay, we have alpha, beta, gamma. So this is something that you have heard before. So let's look at, this is, for example, the decay of uranium, isotope uranium-238, okay, releasing alpha. Alpha is actually helium-4, okay. We have atomic number, proton number, okay. So I hope that you remember your periodic table. And then you can see that the decay of uranium, okay, to thorium. So this one shouldn't be U, okay. There's a mistake here. 234. So it becomes another element, okay, and producing alpha radiation. So this is example of nuclear equations, okay. The isotope uh, trying to stabilize, so it will decay into a new element, okay, and giving out a radiation, in this case alpha. Okay, this is alpha, right? So I'm not going to discuss. There are a lot of naturally occurring radiation, for example, alpha, beta, and gamma. Right, so let's skip this because this is not part of your, we are talking about the energy. So example, the easiest example for radioactive decay or being used in our life is X-rays. Yeah. Okay, let me. All right. So I'm not going to discuss band of stability. It's just band of stability is something that we can use to predict whether it will undergoes alpha emission, beta emission, or gamma emission. Okay. And there are other radioactive decay as well. So these are some applications. So let's, okay. So why is it fission and fusion giving out a lot of energy? Is because it can we have chain of reaction. Okay, you can see that from starting from uranium, it goes down fission. Okay, it can have a chain of reaction. So when it has a chain of reaction, the energy is actually accumulative and bigger, right? And does a nuclear power have a future, or will new technologies of renewable energy be developed? Okay, of course, now we have discussed about a few types of renewable energy. So it's not just nuclear. So this is a real life disaster, okay, that has happened in Japan. So as I mentioned, Japan has quite a lot of, they have significant numbers and they rely a lot on nuclear energy. So this Fukushima Daiichi, it is near to the sea. And what happened in 2011 is the earthquake, a very big earthquake, resulting tsunami. Okay. So what they don't expect is because nuclear reactors needs to be cooled down. Okay. It really has to be cooled down. If not, then you have explosions. So they have a system to cool the reactors, but it requires electricity. So what happened is when the tsunami happened, the the salt water, okay, the salt water destroys they have backup generator to take care of the cooling system, but the salt water from the tsunami destroy, okay, this system and end up that the reactor becomes heated up and explodes. Okay, so that's why it is a disaster, because what we knew that it's not just a simple explosion. It will gives out radioactive particles, and probably they have done some research that the radioactive particles are actually in the sea, and then it moves everywhere in the world that is based on the current of the sea, right? So you can actually watch this. Okay, this is a movie, right? Pandora, but this one is a Korean movie. Okay, so this is not actually based on true story, but you can also watch. Okay, let me share you with something else. Uh, okay, this is a movie based on the story of the Fukushima Daiichi explosion. So it tells you uh, days, hours by hours, what happened before the disaster happened. It starts with earthquakes and then tsunami and the decision making and those who involved in the disaster. So it's a good thing to watch and understand the issues of uh, nuclear re- nuclear power plant. Okay, all right. Okay, and regarding this, uh, let's change to another one. Okay, just end this show first. Okay, before we proceed to the other one, the last one, which is energy storage, I just want to share about the issues that is quite latest. Okay, where is it? Okay, so we are talking about energy. So energy is actually number one. I would say number one business because if you control energy, you control other things like if you're talking about agriculture, food security, or any other business, you cannot continue if you don't have energy. So with the recent war that is happening, not to say war, tension between the countries. So there is issue of Strait of Hormuz. Yeah. So if the Strait of Hormuz, which is the main exit for those exporting oil, okay. So if they close this, then we'll be in big trouble. Okay, so we will have to think about alternative in energy because this the small strait just now that you can see from the picture is just a small, but it's a big impact to the world, especially European countries, because they will not receive a supply of petroleum. Okay, so this is going to impact of course, the price of everything. It's not just about petroleum. It's going to is going to incur costs in any other foods or whatever being exported or imported. Okay, because all requires fuel to move, and if the energy, meaning that the petroleum price is higher due to the Strait of Hormuz closure, then the whole world will be in big trouble. So we need to have alternative. We really need to have alternative. So the reliance on fossil fuel, petroleum, is something that we have to think about. Yeah. So it's good to know about all this. If you are in energy business, then you are on the right track. Okay. Right. So let's move to uh, the second one, which is storage. Stop share this one. Okay, so let's because we cannot separate energy technology with energy storage system. Okay. So if you have installed a photovoltaic cell, solar cell at your home, okay, you are required to also have battery. I mean, what do they call that? I don't remember. Okay, so it's a storage system. Okay, so it is something that you cannot uh, uh, I mean, you cannot have alternative energy, but without the storage system. Okay, so it's like battery. The simple word is battery. So it's another business. If you are in energy business, you can also be in battery business. Yeah. So so it in an energy storage system, in short, ESS, captures and stores energy for later use. Okay, of course, like if you have solar power, solar cell system, then you can capture the energy during daytime, and then you need to sustain during night. And how do we do this is by having energy storage system. So if we are talking about renewable energy and to avoid 100% reliability on fossil fuel, then we have to think about energy storage system. Okay. And we also talking about those secluded areas, okay, where you don't have the grids, is off the grids, then we need to talk about the energy storage system as well. So the energy storage system is not just store, okay, sorry. It also transform electrical energy. How does it work is it keeps the energy into a storable form, okay? Like chemical energy in batteries, the small batteries that you use, the batteries that you use in your car. So they are storing energies, okay? So, so it can store and it can be changed back to electrical energy whenever that we need it. So that's how it functions. So it is like having a potential energy kept in a small box. Okay. Holds the converted energy until needed. Yeah. Right. So two types of energy storage, because we have talked about hydrogen storage as well. So we have batteries. Okay. So some batteries uses like the lead acid. Okay. If you are still using the wet battery in your car, you're talking about the acid and lead. Yeah. Okay. So from time to time, you have to top up the water so that the electrochemical reaction to happen. It generates a small amount of electrical so that you can start your car. Okay. So this is very commonly used in your car, but they also have dry batteries. Yeah, nowadays, I mean, it has been for a while, the dry batteries where you don't need to top up with water or acid. Okay. All right. So another one that, because we already knew discussed about hydrogen energy. So it involves production of hydrogen through water splitting, electrolysis. And so we need to store it and use it in fuel cells to generate electricity. So the hydrogen itself has to be kept, okay, to generate electricity after sometimes. Yeah. All right. So applications, just like what I have mentioned just now, is if we have fluctuation, for example, solar, we can only get daytime, wind power based on the wind. Okay. So by uh, saving it in a system, then we can use it later. Okay, grid stability. So the energy storage system can respond quickly to grid fluctuation. I don't really understand but it's about it's a fluctuation of power, because sometimes daytime or working time, the use of power or the use of electricity shoot up because everybody is working, using a lot of electricity. Whereas at nighttime, probably it is lower down. So that's why having a storage can back up all this. Okay. So providing enough backup power and preventing blackouts. Off grid means that something somewhere not in area, main area, probably secluded area. So as it core battery storage acts as a buffer between generation and consumption of renewable energy. And typically, we know about the lithium ion. So you have your power bank, and some have power stations. So those are what we call as energy storage system, but small one. Okay. So for those of you who like to go camping, they have, you bring your own power station, uh, small power banks. So these are examples of energy storage system, and they usually use this technology, lithium ion. Okay. So you can read about this energy storage from this link. Okay, so this is an example of a big energy storage system. And this is the lithium ion batteries. But as we know that the lithium ion batteries can be dangerous in terms of flammability. It might catch fire or something. Okay. So if you look at the real picture, so this is the size. So yeah, it is still very bulky. So I don't know how much energy can be stored with this size of energy storage system. Okay, so this technology is relatively very new. So there's a lot of material that is currently being developed, okay, to come up with a new energy storage system. So this is a good business for research, a booming business, material for energy storage. So one of it is supercapacitor, okay, also known as ultra capacitors. So these are energy storage device, okay? So how they function is they allow rapid charging and discharging cycles. So this has been used in the bullet train, okay? So they have this supercapacitor energy storage. So it provides a very rapid energy because they have this charging and discharging cycles. So I'm not really into this, so I cannot tell you detail about the charging and discharging cycles. Okay, so but this is one example, and you can read from here. So how they work, say supercapacitors store energy. So you can see basically they have membranes and they have chargers. So supercapacitors store energy by accumulating ions. Okay, so they have these porous electrodes. Sorry. So the ions are accumulated here. So this electrostatic charge storage enable much faster charge and discharge rates compared to batteries. Okay, so batteries requires electrochemical reactions, but this one is just like moving the ions. Okay, so if you have electrical power, then it can move the ion faster. They do not involve chemical reaction. As for batteries, it involves chemical reaction. So that's why probably it is much more rapid in terms of producing electrical power. So in terms of comparison between supercapacitors and batteries, okay, this is battery, this is supercapacitors, right? So supercapacitors store energy electrostatically. As you have seen just now, it is based on ions, okay? So you don't have to do chemical reactions. So their power density from 10 to 100 times higher than batteries, okay? So they can fully charge easily and faster. Battery chemistry reactions occur at slower speeds. Yeah, we know that, which impacts charge and discharge rates. Okay. And in terms of life expectancy, it is longer compared to battery. So rechargeable batteries, they have chemical degradation, wear out. Okay. So supercapacitors have longer lifespan. Okay. And then in terms of temperature, it can operate in a wide temperature range, can function without significant degradation in environment from -40 to 70 degrees. Batteries, especially lithium ion, can't operate across that wide of temperature without overheating. So I'm sure that you have experienced that. If you heat, if you charge your phone, sometimes you have this overheat. Yeah. And there are cases of fire due to uh, overheating or overcharging your phones. So don't sleep with your charged phones. Supercapacitor mostly consists of carbon and is compound, so they biodegrade. Okay, compared to batteries, they usually contain metals. Okay. All right. So high efficiency. So in renewable power generation, energy efficiency is paramount, of course. So during charging cycles, meaning that the charging of the supercapacitors is faster than batteries. So this is the load of power or some parameters when we measure uh, storage, energy storage system. Lead acid, lithium ion, and supercapacitors. Okay. So I don't know which one is the most important parameters. Okay. So what I can say is, what I can see from my layman point of view is power density. So this one you can see that it has greater, right? Cycle life, charge and discharge efficiency. It seems that it is almost similar to lithium ions. Fast charge duration, of course, it is faster, it's 30 seconds. Fast discharge duration, okay, meaning that you can use the energy very fast. Shelf life 20, and operating temperature definitely is also a great advantage. Yeah, supercapacitors. Right. So what are supercapacitors? Okay. So supercapacitors is actually from it can come from 2D nanostructures or 3D nanostructures. I'm not in this line of research, but I think I have heard about graphene supercapacitors. So they are based on carbon. So as we know, carbon is environmentally friendly. So there are also some who which metal oxides, okay, combination of graphene and metal oxide. So you can search for this link. Yeah. So I think that's all, right, from me for the last class. So if you have any question, please do ask. But I don't have any more to share with you. So it's just that if you are interested in a booming business, you can start kicking on energy business, batteries or supercapacitors, hydrogen or syngas. Uh, so this is a great technology to be explored. Okay. All right. So any question? You can use your time after this to complete the assignment. You have two assignment. One is tutorial, individual, and the other one is group assignment. So that's it. And then for our final exam, I have told you that we're going to have open book exam. So the date is 12th July. So for those of you who have experience doing the open book exam that you have from 8 a.m. to 12 midnight to complete it, and it has to be submitted through Putra Blast system. Okay, everybody?
Okay, Prof.
All right. Okay. Thank you.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.